Section 5.2, Exponential Functions. I'll get them for you. We've talked about polynomial functions. We've talked about rational functions. Now we're going to talk about a third type, exponential functions. Here's the basic form. I guess you could call it the parent function. An exponential function is any function of the form a to the x power. So you got variables in the exponent. So we are fixing to start talking about logarithms and all that good stuff. Here are some examples of exponential functions. Y equals 10 to the x power, y equals 2 to the x power, y equals 1/2 to the x power. In the first two examples, a is greater than 1 and represents a function that is growing from left to right, exponential growth. Any function that has an a between 0 and 1, as in the third example, shrinks from left to right or is known as exponential decay. So the first couple of examples would look like this, to where you're starting out slow and then you're growing rapidly as x increases. And the other one, again, I call it exponential decay. You're starting out big and you're actually shrinking as your x is getting bigger and bigger. Below are some characteristics of the two types of functions. And again, like I just told you, if your a is greater than 1, if it's like 2 to the x power, 3 to the x power, 4 to the x power, it looks like this. Anything between 0 and 1 looks like this. Y-intercept for both of them, it's going to be 1, because anything to the 0 power is 1. First one, y is increasing. Second one, y is decreasing. And you can read the rest of it there. Let's go back and review your transformations, because that's the first thing we're going to start out with. Describe the transformation that takes place from f of x equals 2 to the x power to these functions. Notice again, if something's happening directly to the x, it's happening horizontally. If it's happening to the entire function, it's happening vertically. So on a part, you're going from 2 to the x power to this. So you've got a plus 2 tacked onto your x. Do you remember what that's going to do? It's going to move it to the left 2. It does opposite. Plus 2 is going to move it left 2. B part, you have a minus 1 tacked on to just the x, but then you got a plus 4 tacked onto the entire function. This moves it to the right 1. The plus 4 tacked on the end moves it up 4. 2 to the 0.3x. By the way, what's 0.3 as a fraction? That's 3/10. 0.3, 3's in the tenths place. That's 3/10 x. So let's go back and review again. If it's happening to the x, okay, it's going to be either a stretch or compression. Since it's happening to the x, it's happening horizontally. It does backwards what you think it would do. 3/10, you got to flip it. It's going to stretch it times 10/3. Makes sense. Again, this is 3/10 x. If you want to rewrite it as 2 to the 3/10 x power. Okay, since it's happening to the x, it flips it, does opposite what you think it would. That's going to stretch it times 10/3 instead of compressing it. 2 to the negative x power. Again, the negative's on the x. It's going to flip it which way? Horizontally. 2 to the negative 2/3 x. Again, it's applying to the x, so it's going to flip it because of the negative, and it's going to stretch or compress it. Stretch it times what? 3/2. Good. Next one's 3 times 2 to the x. Notice the 3's being multiplied by the whole thing. So it's going to be vertical. Yeah, stretch it times 3 vertically. Next one, you've got two different things happen to it vertically. It's going to flip it vertically because of the negative, and the 4 is going to stretch it vertically times 4. And the last one, you got a ton of stuff happening. The x stuff happens first. So let's go in here to the x stuff. Now it's not going to move it because you don't have any pluses or minuses. Negative flips it. Good job. Negative flips it horizontally, so it's going to flip it across the actual y-axis. The 4/10 does opposite what you would think it's going to do. Since that's 4/10, it's going to do 10/4. It's going to stretch it times 10/4, which is 2.5. So it's going to stretch it times 2.5 horizontally. The negative 5 out front. Good job. Flips it vertically, stretches it times 5 vertically, and the plus 3 on the end moves it up 3. So that's just a good review of your transformation. The rest of this lesson is going to be really easy. It's pretty much just plugging stuff in. It says if you invest $2,000 in a stock that's increasing at a rate of 2% per year, then the value of your stock is given by the following function. So you don't even need to know the information up the top. That's just, they give you the function. Later on, you're going to be asked to find it. I am going to go ahead and kind of explain to you where this function came from. You start at $2,000. After 1 year, if you plugged in 1 there, you're going to multiply it by 1.02 once. That's increasing at a rate of 2%. This is actually, though, 102%, is it not? 1.02. If you increase something at a rate of 2%, it grows times 102%. It's what it was originally plus an additional 2%. So it's now 102% of what it was before. So that's where the 1.02 comes from. Assuming that your value of your stock continues to grow at this rate, how much will your investment be worth after 7 years? So where's the 7 go? The x. So all you got to do there is 2,000 times 1.02 to the 7th power. So let me pull up my calculator. So again, we have, all we got to do is 2,000 times after 7 years. So f of 7 is what you're finding. 2,000 times 1.02 to the 7th power. So you can just use a calculator. That's all you're doing. 2,000 times 1.02 raised to the 7th power. Enter. 2,200. Your investment has grown $297. So it's now worth $2297.37. $2297.37. So yeah, $297.37. One thing I would like to caution you of: could you go ahead and multiply 2,000 times 1.02? No. That's probably the most common mistake made on these. Don't do that. Okay. This B part, second part of that says, find the value for which f of x is 3,000. In other words, solve the equation, and it gives it to you. What it's asking for is how many years would it take for your investment to grow to $3,000? Give me a guess. After 7 years, it grew to, let's go back to it. After 7 years, it grew to that. So, how long do you think it'd take to grow to 3,000? That's 28 would be a good observation because you're doing times 4, but you got to be careful about this because it's exponential growth. Yeah, you're growing exponentially. So I'm thinking, my guess is 15 or 20. Okay, so again, all we're doing is solving 2,000 times 1.02 raised to the x power equals 3,000. We can't solve it algebraically today. Later on in the chapter, we'll teach you how to do that. We can do one step algebraically. Let's move the 2,000 over. You get 1.02 raised to the x power equals, how do you move it over? Divide by 2,000. If you divide that, can anybody do that in your head? Should be able to. Zeros cancel. 3/2, which is 1.5. To solve that, this is the only method we have thus far, using that Intercept Method or the other, I can't remember what they called the other one. You do y equals let's move that back over to solve it. So 1.02 raised to the x power minus 1.5, and just look for the x-intercept. As of right now, that's the only method you have to solve it. Between 20 and 21, what did I say, 15? That's close. So yeah, you can see it's getting close, and we're looking for where it's going to cross. So since you're looking for the x-intercept, what you can do is you can cut out all these extra y's. On your window, what I normally do when I'm looking for intercepts is my window, I'll just run from like -2 to 2, since I'm just interested when it crosses. And since your x's are actually years, let's start it at 0 and go up to 25, and we'll increase it by 5 each time. So you got 5, 10, 15 years, 20 years, somewhere around 20 years, but let's do second calc. We're looking for a 0, so it's somewhere between 10 and 25. Doesn't matter what you let your bounds be. So it takes right at 20.5 years. 20.4, we'll call it x equals 20.5. Again, you've never solved equations, or actually you have in Algebra 2, but this year you haven't solved equations where you have x in the exponents. That's to come later on with logarithms. Next problem.